Okay guys, this is the plan. I want to spend the morning taking one of the assemblages that we talked about yesterday. We talked about communities, organizations, social justice movements, federal governments, industrial networks, cities, and so on. We could take any one of those and then flesh it out. Because yesterday we were dealing with the models of these things, very streamlined models. I try to keep everything very simple, precisely because that's the way models work. But eventually you have to flesh out those models with a little bit more detail. So I could make materialist history of communities, I could make materialist history of organizations, I could make materialist history of any of the assemblages that we did yesterday. I'm going to pick cities because it's the one that we ended the class with last night. Right? So I want to spend the morning talking about a few aspects of the materialist history of it. You know, when you talk about cities, the important things immediately come to mind is where do they get their water? Where do they get their food? Right? I mean, that's the material life of cities. Also, there are specifically urban diseases, contagious diseases. You might find that kind of hard to believe, because of course microorganisms cannot tell whether they are in an urban environment or not. But a city as a dynamical system, in the sense of a tightly packed people in a particular space, creates very special epidemiological conditions that allows certain diseases to survive only in an urban environment. Right? So that would be another part of materialist history of cities, the epidemiological history of cities. And in the second part of the class this morning, then I want to show you how we can make a materialist history of language, right? Also based around this particular assemblage, the city assemblage. So with that, it's going to be less theoretical, it's going to be more historical, so I'm going to be giving you more historical details. But is the way in which I would propose fleshing out the model that we studied yesterday, right? And the same treatment can be done to any of the other entities that we saw yesterday. Then when we come back tonight, switching gears again back to Deleuze, I kind of try to give you a better view of the Deleuzian ontology, again based on science, because that is my take on Deleuze. I'm not going to use his books on cinema, I'm not going to use his books on art. I'm just going to talk again about the Deleuzian world and how is it that, talk a little bit about materialist ethics that I mentioned yesterday in passing when talking about Spinoza, right? So we'll end up in a more theoretical note, but I want at least to start the morning with a more concrete historical vision of what, how the theory of assemblages can then flesh out the models that we talked about yesterday. So I'm going to use a long period of history. I always do that. Many historical processes don't play out their consequences until 500 years or 700 years later. So you normally have to take an 800-year or 1,000-year time frame. 1,000 years is a good one. It's a whole millennium. In order to really see the historical consequences in their full time, in their full temporality, okay? So I'm going to concentrate on Europe, mostly because we need to stay focused, and because we already did a little bit of work on this yesterday. And so, let's begin then. The birth of Europe, 1000 AD. 1000 AD is, of course, 500 years after the fall of the Roman Empire. Cities have declined tremendously, although every city of Roman origin still exists. I'm going to put another little chart here. But if we chart the millennium in terms of cities. So we would have to, of course, start talking about rates, speeds of becoming. The main speed of becoming that we need to talk about, of course, here is the rate of urbanization. What is the rate of urbanization? Well, partly is you take for every year how many cities are born that year, meaning how many rural villages became small towns, how many small towns became medium-sized towns, how many medium-sized towns became large towns, and then you subtract how many cities died that year, whether from famines, whether from war, whether from epidemics, right? And that is the rate of growth in the number of cities, right? So if we chart the rate of urbanization in Europe from the year 1000 to the year 2000, the curve, which I'm going to simplify, is actually very interesting because it goes like this. This is 1300, this is 1500, this is 1800, and the rate of urbanization actually keeps going, but 1920, that's why I'm tapering it down, 1920 is roughly the year in which suburbs in the United States and elsewhere begin to compete on an equal basis with cities for people. Now, cities grow when the population grows. It's not as if just the infrastructure of the city grows. It's the entire assemblage. City with its communities, with its organizations, and with the people that staff those organizations and are members of those communities, right? It's an assemblage of assemblages of assemblages. And as suburbs begin developing, particularly with the development of the railroad, particularly when Boston created a flat fare, it was a flat nickel fare, which for the first time made it available to working class people, all kinds of different suburbs began forming outside of cities, middle-class suburbs, working-class suburbs, rich people's suburbs, and they began to compete for people with cities. And around 1920, the population inside central cities begins to decline relative to that of their suburbs. But if you think that the suburbs are still part of the city, it's not as if there was an overall decline. That's why I'm putting that dotted line to say it continued to grow. So the curve goes like this. Starting in the year 1000, there is an incredible upswing in the rate of urbanization going from the year 1000 to the year 1300. That should be amazing to anybody who has ever heard that, well, feudalism came first, then capitalism, then, because that is the time of feudalism. It's supposed to be non-urban. So how is it possible that so many cities were born between the year 1000 and the year 1300? Well, they were born in the areas that I marked yesterday, of course. Northern Italy, Flanders, the United Provinces, Northern Germany, and the cities within the feudal areas, the areas that eventually became Spain, the areas that eventually became France, the areas that were already England, because England was premature or precocious in that regard. Their cities also grew. The capital cities, Paris, which is of Roman origin, London, which is of Roman origin, but many new cities, like Venice was born around 900, when people from the different lagoons came together and formed what was at first a very small town. Amsterdam was born in this upswing. So this upswing should give you pause when thinking about history, because Europe was more modern in a way prior to 1300 than during this downswing. This downswing occurred for a variety of reasons. I'm going to explain them right now. Having to do, Europe experiences its first ecological crisis in 1300, because of course, if you're going to urbanize at this speed, you're going to have to deforest at that speed. A city is basically, you clear the forest and then you can build a town. You need enough agricultural land to feed the city, and so if all these new cities are being born throughout, then the temperate forest, which was the ecosystem which Europe was and still is, had to be taken down. Now you deforest in a careless way for 3 consecutive years, and particularly when you begin deforesting in slopes, and erosion begins taking topsoil away. And topsoil is, of course, the reservoir of nutrients that is, together with sunlight, is necessary for your crops. You lose topsoil, you kill yourself. Right? There's a very interesting book called Topsoil and Civilization. I can't remember the name of the two authors, two historians, and it's a very wide-ranging book because it begins in 2000, 3000 BC and goes all the way to present time, and just documents how many cities, how many urban civilizations or urban cultures have died or have gone extinct because they did not take care of their topsoil. Right? Even though we already, from the Phoenicians, knew that terracing slope allows you to prevent the erosion of topsoil, many people just failed to implement any kind of measures, and they were carelessly deforesting. And according to the authors, most urban civilizations on the planet have been able to pass their genes only 70 generations, not all of them, but many of them, before they run out of topsoil, before they run out of resources, right? So something like that was happening to Europe by 1300. They were already having an ecological crisis due to crazy deforestation. And then, of course, they were hit by the bubonic plague in 1340, and the bacillus of the plague just found it easier to move from one undernourished mass of peasants and an undernourished mass of urbanites to another undernourished mass of, in other words, where their immune systems already compromised, and eliminated a third of the population of Europe. Remember, yesterday I was telling you that culture exists only as the memory of any of those entities that we've been talking about. Personal, biographical memories, communal memories, institutional memories of organizations, urban memories. Well, those memories are erased when a third of the population, or at least compromised when a third of the population dies. And that is what happened. That is why we forgot about this upswing. That's why we kept talking about this as the Dark Ages, even though they had nothing dark about it, in the sense that they were, look at this upswing. This was an incredible intensification of commerce, an incredible intensification in the production of food. There's an agricultural revolution that happens between 900 and 1000. It's an agricultural revolution which by our own standards is not really that amazing, because it was just basically using the horse for traction, which wasn't used before. You needed to invent a special horse harness, of course, to be able to tap into the muscular energy of the horse. You needed to invent the horseshoe to be able to make that horse last longer in the field. And they invented a system of rotating their crops so that half of the land was planted with human food, half of the land was allowed to lay fallow, as they say, which means you don't plant anything, you allow the minerals to recover. All you have to be doing is taking out the weeds. You need to work the land, but nevertheless you don't plant anything, and then you rotate the following year. And that system of biennial rotation, I believe, increased the productivity of the land, with the horse now as a machine, because now you have the harness to be able to tap into his muscular energy, and you had given him durability with the horseshoe. The amount of food that began flowing through Europe increased enormously. Prices, for the same reason, dropped. Families began planning larger families because they saw food is cheaper. We can actually have larger families. As it is, people had larger families just as an insurance against disease. When we get to the part of the disease, we'll talk about that. So this curve is very interesting. Then there's, of course, the downswing that comes from the ecological crisis and the bubonic plague. And then there's another, a recovery after the Renaissance, right? But most people think that Europe was born here. This is why it's called the Renaissance. But no, this is the birth of Europe. That is the real upswing that we need to explain and that we need to dedicate some time to. The second upswing was also due to an increase in the amount of energy running through the system, only this time was not energy in the form of chemicals, in the form of sugars in grain. Right? Remember I told you, I believe it was the first lecture, that all food chains begin with the primary producers, which are plants. plants take the first bite of the food chain, so to speak, by biting into the solar stream, by biting into electromagnetic radiation, and transforming via photosynthesis that radiation into sugars. Sugars are chemical molecules that are capable of storing a lot of energy. Then herbivores eat those plants, convert that energy into muscle. Predators eat the herbivores and convert that muscle into further muscle, and the food chain continues like that, right?
Excuse me, does the fact that you have rate of urbanization y-axis mean that even from 1300 to 1500 people go to the cities because it is not negative?
Well, no, the rate of urbanization refers right now exclusively to the birth and death of entire cities.
Yeah, no, I understand, but from 1300 to 1500 it's still above zero. Does it mean that cities were still growing?
Right, you mean before the year 1000?
No, between 1300 and 1500. I mean, the growth rate drops, but it's still above zero.
Oh, here?
No, between 1300 and 1500.
Oh, I'm sorry. Oh, here?
Yeah.
Well, no, actually, many cities declined.
Yeah,
In other words, the rate of urbanization declined. That basically means that large cities became medium-sized cities. Medium-sized cities became small cities, small towns. Many small towns became either disappeared or became villages again, like rural villages. Well, you know, a third of the population was lost. So that means that, you know, there was a general depopulation. There was no, cities grow when people grow. This is why an injection of cheap food was absolutely necessary for this to happen, right? The second injection for this second upswing here was, of course, now fossil fuels, right? Coal begins to be exploited in England in the late 1600s. By the early 1700s, the steam engine has been invented, and so now you have something to do with that coal. Coal had been mined by the Romans and other civilizations, but they never invented a machine that could actually take advantage of it. Now remember what fossil fuels are. Fossil fuels are just the corpses of plants and animals that died a long time ago, millions of years ago, and were deposited, were buried in such a way that there was no oxygen. Because normally the corpses of plants and animals are disintegrated by microorganisms right there on the spot, and microorganisms disassemble the assemblage and re-inject those minerals into the soil, but those microorganisms are aerobic. They need oxygen to operate. If plants and animals, for whatever reason, they get buried under, you know, volcanic ash or volcanic lava, or for any particular accident, in such a way that there is no oxygen where they are buried, those microorganisms cannot take them apart, and that energy that's captured in the bodies of plants and animals becomes mineralized very, very slowly at very intense temperatures, very intense pressures, and eventually is transformed into oil, coal, and natural gas. Right? That's what we call it fossil fuel. It's not necessarily that it comes from bones. It's mineralized bodies of plants and animals, right? That have traveled the way back to rocks and become coal again. So as we began mining those and we invented the steam engine, there's another upswing up to 1800 that is again caused by that injection of energy. Right? So we're talking about a very material history here. Actually, let me. Now, let me actually go back to this. in the year 1000, we're going to start a story. The Roman Empire has been gone for 500 years, and therefore the deforestation that the Romans themselves did, because the Romans also deforested everything and ran out of topsoil. That's why they had to invade Egypt and begin importing food, from their colonies. But after 500 years of decline, this was already a temperate forest. In other words, the forest had put itself back together. An ecosystem puts itself together through what is called a process of succession. Let's imagine a volcanic eruption or some geological cataclysm that kills an ecosystem and leaves just a disturbed land without any plants in it, just to imagine what the process is. And of course, the process of succession varies depending on what type of ecosystem. If it's a tundra, if it's a rainforest, if it's a temperate forest, and so on. But the first plants that move in, the first stage of succession, are plants that have opportunistic reproductive strategies. Meaning they can reproduce throughout the year. They are not annuals, right? And they take advantage of that. They are the first colonizers precisely because they can reproduce throughout the year, and so they find any piece of disturbed soil without any other plants in it, that's the perfect place for them to move in. Then those plants begin to tie, with the roots, begin to tie the soil together. They begin to give structure to that space. And a second generation of plants, in this particular case, is lichen and moss, begin to move in, taking advantage. Now they can be annuals, they can reproduce themselves every year because now the soil has been structured by the roots of the first colonizers, so the second ones now find a place that has been prepared for them. After those relatively small-sized plants have moved in, a pine forest can begin to develop, again, only in a temperate ecosystem. And the final climax vegetation contains oaks, elms, beech trees, and other varieties, and that is called the climax vegetation because that is the final forest. That is the culmination of the process of succession. So Europe had gone through that process of succession in those 500 years. All the disturbed land that the Romans had left had been invaded by those plants with opportunistic reproductive strategies, and lichen and moss had moved in, then a pine forest had emerged, and eventually a mature forest of oaks, elms, beeches had taken over entire Europe. And then came, of course, a process of deforestation. Everywhere, wherever there was a city, you had to clear a certain amount of, if the city is this dot points, you have to start clearing a circle around them with enough arable land. I'm going to zoom into that circle right here. And this is the year 1300 AD. These are Brodale's calculations. He says, a town of 3,000 inhabitants in the year 1300 is just a ballpark figure, right? We would have to make this calculations town by town, but I want to give you numbers just so that you understand that we're talking about a very concrete thing here. A town of 3,000 people, which in the year 1300 was a medium-sized town. I mean, 3,000 people today doesn't even count as a town, right? The census people won't even count it as a town. But you have to remember that in the year 1300, feeding 3,000 people, providing water for 3,000 people, providing services for 3,000 people was a hell of a lot harder to do than it is today. So a town with 3,000 people was a fully urbanized place. A town of do you guys can see this? Should I move it back a little?
It would be great if you move it in the middle.
Oh, more towards the middle? Because I can see you squinting.
Yeah. There you go.
I can see you squinting. You can't see. A town of 3,000 people needed to deforest at least 8.5 square kilometers of land, or the equivalent 10 rural villages. And of course they needed the peasants and the farmers there, not just the arable land, who would come then to the marketplace, to the bazaar in the city, and exchange those things for manufactured products and feed the city. But cities needed to control this area. In other words, they needed to make it illegal for those villages to become towns. They needed to impose their own regulations on those villages. What the way urbanists and urban historians call this is towns project or cast an urban shadow in their surroundings, because they cannot allow other towns to come in and compete for people for them. They need to actually attract all the migrants that they can from that catchment area, and they need to keep it free of other cities because they're going to feed off that land. Now imagine that you are in the year 1300 and this is still forested. You know, you just clear those 8.5 square kilometers. What do you think plants out here would look at this and see? I mean, if they could have eyes. Well, they would see a piece of disturbed land that looks like a volcano just erupted, or some cataclysm just cleared the land. So they are going to try to move in again. And they're going to try to restart the ecosystem, restart the process of succession. The plants that are going to move in first are, of course, the plants with opportunistic reproductive strategies. And those plants we now call, or we have been calling for many centuries, weeds. But weed is not a biological term. Weed is a social term. There is no such thing as a species of plant called a weed, or a family of plants called a weed. A weed is simply any plant that tries to put the old ecosystem back together. And you have to prevent it from putting the old ecosystem back together because you don't want a forest to grow around your city, right? So we weed them out. One of the forms of labor that's the hardest for all those 10 rural villages is precisely just to keep that land free of weeds, right? But that shows you that the limit between nature and culture, to use two reified generalities, and as you can see I'm blushing just by doing that, is not sharp, or rather it has to be kept sharp by day-to-day work. The very fact that you have to be keeping those weeds out means that your job is never done. You've demarcated a place for civilization in the middle of a natural forest. But the forest is going to try to come back in all the time. And you need to keep weeding them out.
Also, isn't this around the time that I live in the UK, and there's all the tales of the evil forest, that you're doing God's work by destroying the forest? So there's like this social thing that's happening too.
Exactly.
Yeah.
Well, yeah, exactly. They were in fact specialized monks,
yeah,
right? Who
because
if you just grew out of the Dark Ages, this is like the birth of Europe, and everything is this dark forest. You do believe that it is inhabited by demons, right? I mean, it was dangerous, as a matter of fact. There were wolves in those forests. There were bears in those forests. In other words, we were not the top of the food chain in the year 1000, right? And going from one town to another town in the year 1000 was actually dangerous between the year 1000 and 1300. Right? Once all those cities were there and there were roads, it was different. There were thieves and it was still dangerous to go through those towns, but not because of wolves and bears. Right? But in the first 300 years, going into those forests was dangerous, and of course, myths began to grow around the fact that they were inhabited by the devil. Special armies of monks, you're absolutely right, took it as their calling to deforest everything they could like crazy, right? Crazy monks. What do I know? So, a town of 3,000 people, and you always need to be keeping weeds out. What I think is interesting about this is precisely the idea that the limit between nature and culture needs to be constantly, day to day, reaffirmed. This shouldn't come as no surprise because it's emergent. Right? Those limits are emergent. And things that are emergent need to be maintained every day. After the year 1300, of course, many towns began buying their food from far away. There was enough commerce. Commerce was regular enough and reliable enough that you could either change your arable land and grow cash crops, things that were exclusively for sale, but not to feed your own people, and you could start importing food from farther and farther away. Now, Jane Jacobs, she is an urbanist, Canadian urbanist who died recently. All of whose books are beautiful because she is one of those persons who loves cities, and so she writes books, the wealth of cities, the economies of cities. Every book has the word city in it, and you can see the love for cities that she has. And so I highly recommend. There are little books that you can read in a weekend, and they just give you that, if you want to know cities as assemblages, it's a perfect place to start. She coined the term supply zone. For any area of the world, including the rural areas around cities, that are deliberately kept underdeveloped by cities so that they become providers of food. Right? Cities know that they cannot, in fact, as far as I can tell, and I don't, you might be able to find another piece of data that contradicts me, but I don't think there has ever been a single city in the history of humankind that has fed itself. In other words, every urban center, as far back as Mesopotamia and Egypt, was parasitic on their countryside or parasitic on colonial lands somewhere else. But there was always a supply zone. Cities had gardens, vegetable gardens inside. Cities could have some food grown inside, but it was never enough to actually keep the town alive. Right? So they had to conquer supply zones and keep them underdeveloped. The first type of supply zone is, of course, the adjacent countryside, as we see here by the year 1300. But starting in 1300, cities began either changing their countrysides to cash crops and importing food from other supply zones. And this is the beginning of colonialism. The first colonial adventure of Europe, if we don't count the Crusades, although that would be obviously the very first colonial adventure, is when Europe colonized itself by 1500. With wholesalers from Amsterdam at their lead, and making alliances with feudal lords and in Eastern Europe. Almost the entire Eastern Europe, starting in 1500, was transformed into a supply zone, meaning cities declined. It's sort of like east of Poland. So that there were already big cities like Prague. Prague has a university from the 11th century. Eastern Europe was growing just like Western Europe was, but once wholesalers from Amsterdam, in cahoots with local feudal lords, began transforming that area into a supply zone, we enter an era that is called the second serfdom. It's like a recreation of feudalism at a much larger scale to create a supply zone for all Western cities, who now were feeding themselves from food that was coming from Eastern Europe. And of course, Eastern European cities declined. They didn't die altogether, but they stopped growing, and many of them declined to the size of rural villages again. And they began just exporting food for the Western cities. Right? Eventually, Europe ran out of food from Eastern Europe, and with the discovery of America in 1492, an entirely different chapter began, transforming the North American country into a supply zone. Not only the North American country, but Australia, New Zealand, Argentina, into supply zones for the cities of Europe past the year 1500. Here I'm going to be using, his name is Alfred Crosby. It's a beautiful book. The name of the book is Ecological Imperialism. And it's about that, right? The ecological side or the ecological take on the colonization of the world by European cities. And Crosby has a very interesting thesis in that book. He says Europeans went everywhere, of course. Europeans went to India, Europeans went to Indochina, Europeans eventually conquered China and Japan. Europeans eventually, of course they colonized the coasts of Africa and eventually Africa itself. But there are certain areas of the world that they transform into supply zones, which he calls Neo-Europes, because they also had a temperate forest and a temperate climate. Temperate areas of the United States. The United States, you always need to clarify this because the United States has 6 or 7 different ecosystems, right? It can go from tundra to desert to swampy land back in Louisiana, down by Louisiana. So we're talking here obviously the northeastern part, the part that is almost identical to Europe as far as an ecosystem goes. Canada, Argentina, Australia, and New Zealand. The temperate areas of those 5 zones were transformed into gigantic supply zones. Cities were allowed to grow, of course, daughter cities of European cities, but they were not allowed to propagate in the same way as they were doing. In other words, the rate of urbanization was never the same as it was in Europe, and it was on purpose. Europe needed to feed itself from the lands of these areas. Now, the reason why he calls them the Neo-Europes is not only because they had a temperate forest, but also because Europeans had to move in and transform that temperate forest into copies of Europe. And the way they did that is not by just moving people in, but by moving people, their domesticated plants, and their domesticated animals. It was the entire assemblage. Humans, pigs, cows, horses, and wheat, barley, and other standard crops that moves from Europe into these areas and transforms these areas, the temperate areas of those zones, into copies of itself. The reason why domesticated animals are needed is because they can act as, okay, let me just introduce a term here. What circulates in a food chain, and I think I already mentioned that term, is of course flesh, right? The flesh of vegetables that then becomes the flesh of herbivores that then is eaten by carnivores. Now, ecologists don't like the term flesh. It's a little too porno perhaps for them, so they use the term biomass. So let's use that term. Biomass is what circulates in a food chain, right? It can be chewed up vegetable flesh, it can be chewed up, as long as it's energy and nutrients that's circulating through an alimentary chain. So domesticated animals serve the colonists as biomass transformers and biomass storage devices. Let me give you 2 examples. Cows transform about 1/5 of what they eat into something that we can eat. And cows can eat cellulose, which we cannot digest. So if you feed, cows all the cellulose, everything you cannot eat, grass, the stems and leaves of corn or wheat and so on, all that cellulose that's humanly undigestible, you feed it to cows. As they pass through their 7 stomachs, they become eventually flesh, they become eventually milk, and we can now eat it. So cows act as biomass transformers. They transform human inedible food into humanly edible food. So if you don't have cows as part of your assemblage, all that biomass that's unedible goes to waste. Pigs are actually even more efficient than cows. Cows transform 1/5 of what they eat into humanly edible stuff. Pigs transform almost half, except that pigs also eat carbohydrates, which we could also eat. In other words, they don't transform cellulose into meat. Nevertheless, pigs can serve as storage devices, in the sense that the surplus carbohydrates from a particular harvest, particularly if it was a plentiful harvest and there are only a few colonists, and you can store a harvest for a couple of years, you can pickle it and store it for any longer periods of time. You feed it to pigs. Pigs convert it into meat, and they are alive. They are live storage devices. 10 years later, 15 years later, you can then kill the pig and eat the meat, and it's as if you were eating the original food that you fed it. Right? So I like that idea of an entire assemblage of humans, domesticated animals, transforming or storing biomass, and of course, domesticated plants that are connecting us via photosynthesis to the solar stream. Right? This entire assemblage that is capable of feeding cities. And so it was humans and their extended families of domesticates that invaded and eventually colonized the Neo-Europes. But also, they were followed by weeds. Alfred Crosby shows you how in New York and certain parts of the East Coast, you cannot find a weed that is of local origin, which means that European weeds came hidden in seeds in boots or in wooden planks in boxes or even in the stomachs of cows, and were transported in the same ships that came to America. There were of course local varieties of weeds in America or the rest of the Neo-Europes, but particularly in America they had not seen heavy grazing by large quadrupeds, except in the areas where the buffalo roamed. Many of the other quadrupeds had already gone extinct before, and they certainly were not accustomed to cows feeding on them all the time, grazing on them all the time, goats, sheep, and so horses. And so when the Europeans came with their animal partners, the local weeds suffer a shock. They were all of a sudden all these new animals that they had never seen, and they began to leave empty spaces and began to die out, and the European weeds immediately took their place. Right? Today, as I said, if we are to believe Crosby, the European weeds won that competition. They won their own colonization competition. Right? Crosby shows you by reading diaries of ranchers, that were accompanied. Remember that the United States had a moving frontier, right? The English conquered the East Coast, but everybody started moving west. And as they began moving west, ranchers in the wavefront, so to speak, would take their cattle, 1 kilometer, 2 kilometers ahead of the human settlements to graze, and they would write in their diaries, we're finding European weeds here, which means that the weeds were moving west faster than humans were. Not only that, certain fruit trees that the Europeans had brought, like peach trees and orange trees, acquired weedy behavior and began propagating like crazy through the land, to the point where, let me see if I can draw a little map of, and I'm going to make it square too, so as to match the other one. That's Mexico, that's South America, and that is Florida. That just looks awful. You know what I'm talking about, right? That's Mexico, that's the United States, that's Central America, that's South America. That's the best I can do right now, guys. So, colonizers moved here. As the front began moving west, both weeds and fruit trees like peach trees and orange trees began moving ahead of the human wave, which means that Native American Indians on the West Coast first saw, a peach in a river, or an orange in a river, or just the weeds that they had never seen, and they began seeing signs that something was happening. Right? They had never seen a white person but they could almost feel that white people were coming, right? Because their ecosystem was changing. Perhaps an even better example of how we disturbed their ecosystem with the species that we brought in from Europe is the fate of horses. Horses were brought, there were no horses in the United States or in America, right? Everybody knows that. They might have been horses thousands of years ago, but they had been driven to extinction by the first wave of people that came through the Bering Strait. So all those wild horses that you see in Westerns were European horses that had gone wild. Now let me explain this. When we domesticate animals, what we basically do is we take over their genetic apparatus. Right? We begin selectively mating them, selectively breeding them, to eliminate certain undesirable characteristics. For instance, the tusks of wild pigs begin disappearing. Their stringy hair begins disappearing, and now we have that kind of like pinkish, almost hairless kind of pigs that we have. We make them into adolescents. We infantilize them by domesticating them. But it takes a lot of care. You need to be constantly watching, constantly monitoring that selective breeding for the horses to be the horses that we want, for the pigs to be the pigs that we want, for the cows to be the cows that we want. If you let them go wild, by mistake or on purpose, they go what is called feral. They're feral. They're feral dogs, they're feral horses, they're feral pigs. For instance, pigs that were brought to Australia and escaped and went wild became razorbacks. In other words, they just reacquired many of the repressed characteristics that human breeding had kept in check. Cows went wild in Argentina, and enormous herds of wild cows you could be seen roaming in the countryside, and most particularly horses went feral. Right? So the conquistadors brought horses to Mexico City. Some of them went feral, and in their natural state, horses are migratory animals. So some of them began migrating north. And as they migrated north, they began passing by Native American settlements who had never seen a horse. Again, these Native Americans had never seen a white person either. They were just seeing changes in their ecosystem, but they were just seeing signs or symptoms that something was coming. Now, a horse is almost by its very nature a war machine, in the sense that if you mount a horse, it doesn't matter what you hold in your hand, it can be a broomstick. Right? And whatever you hit at a good speed with that broomstick, you're going to kill. Because if you're well mounted, you're well attached to the horse, you're forming an assemblage with the horse, and you inherit the momentum of the horse. That is the speed multiplied by the mass of the horse. Horses are, of course, much more massive than humans, they're much more faster than humans, and so the shock value of a horse is much greater, and you inherit it simply by mounting it and staying on top. Then whatever you have in your hand will become a weapon. Right? This is the reason why the very first example of an assemblage that Deleuze and Guattari give is the assemblage of the mounted archer. Right? The assemblage animal-human technology. Technology in this case being bow and arrow. Right? As long as you assemble them together, they become a war machine. Well, this is exactly what happened to these feral horses. At first, the Native Americans didn't know what to do with them, but a couple of them, the Apaches and the Comanches, immediately saw this potential. They began to tame them and to mount them, and all of a sudden, they had a war machine. All of a sudden, they had much more military power than other Native American tribes, and began fighting against their own neighbors. In other words, we were disrupting their social ecology via a flow of horses that had escaped from one of our cities. And I keep saying our as if I was European, right? But maybe because I'm white. But Europeans disturbed everything with their presence, disturbed the natural ecosystem, disturbed the social ecosystem, even before they actually engaged in genocide, as eventually, they were killing hundreds of people in different towns and so on. Even before it became ugly like that, we were already disrupting them via flows, via material flows, in this case, a flow of horses, which it's always blown my mind to think in those terms. At any rate, today, we know that these areas, the temperate areas of the Neo-Europes, are the areas with the highest photosynthetic potential in the planet. Now, there's more sun in the tropics, of course, but in the tropics, first of all, it's very foggy, and that absorbs a lot of the sunlight. There's a lot more tropical diseases, so it's much harder to create colonies there. And most importantly, there are not long summers in the tropics. You know, the days are all the same length throughout the year. It is only in the northern parts, and of course in the southern parts, because we're including Argentina here, that you have lots of sun, perhaps not as much as the tropics, but without that haziness, so you can use it all. And then you have those long summer days that European crops needed. Right? So what Europeans did by taking over these places is basically to take over the most productive lands in the planet. There is no other places in the planet today that produce food surpluses more than these areas. That is food surplus, meaning the food that is left after you have fed your population. So without knowing it, because they did not do this by calculation, Europeans created copies of their cities in all these places, brought copies of their assemblage of animals, plants, and humans, and created supply zones that continued to feed Europe well into the 19th century. Another commodity that eventually began flowing towards Europe and that changed their alimentary habits was sugar. In the 17th and 18th century, sugar was a medicine. They knew about sugar, they could produce sugar, but it was very expensive. And it was really treated as a medicinal substance. People did not add sugar to coffee, people did not add sugar to tea, people did not add sugar to bakeries, and so on. But of course, once slave plantations in the Caribbean and the United States began to produce enormous amounts of sugars with slave labor, and enormous amounts of sugar began flowing from the United States to Europe, suddenly sugar became cheap. We're talking now about the 19th century. And particularly in England, the dietary habits of people began to change to include this new cheap source of calories. Right? For the first time, people began adding sugar to the tea, spoonfuls of sugar to the coffee, began adding sugar to all their bakeries. Sugar became part of their diet, and it was so cheap that it allowed to keep wages low during the Industrial Revolution, and therefore allowed the accumulation of wealth in those factories by depressing wages, or at least by not allowing wage inflation, right? Because wage inflation always goes with food inflation. Here you were all of a sudden sending an enormous flow of pure calories. Remember, sugar is the very first substance from photosynthesis over to Europe, and once the dietary habits changed and people began consuming cheap calories, well, their wages began to stagnate because they could feed themselves with the same amount of money, and you stop that wage inflationary spiral that could have eaten all the profits of the culture of the Industrial Revolution. So there's a variety of things that we can talk about here surrounding the subject of food. I'm going to stop here. There's a bunch of more stuff that I could say, but this is just a reminder that whenever you talk about cities, and in fact, whenever you talk about any of these assemblages, one of the things that you're going to have to do is not just the part to whole, and these are the emergent properties and so on, but you need to begin working out the material conditions for their existence. Where do they get their water? Where do they get their food? You know, where do they get material supplies for buildings, for weapons? Where do they get their metals and so on? There's all those flows of materials that we need to be talking about right now. I'm going to switch to another type of flow, the flow of genes through generations. I talked a little bit about that right now when I said that we take over the genetic apparatus of pigs, of cows, of horses, and of course of domesticated plants in order to make them ours. But there's another flow of genes that we do not control, the flow of genes through microorganisms. You know, when we discovered penicillin in World War II, we were basically milking it out of bacteria, not going like this, but putting millions of bacteria in a vat. Penicillin is a weapon that bacteria create to fight other bacteria, and so we began taking their weapons and using them against them. We thought at that point that we had finally taken over, that we had finally domesticated microorganisms. After all, we were milking them for penicillin, for antibiotics. Well, today we know that every human disease known to medicine has at least one strain that's antibiotic resistant. All we did was push microorganisms in one direction and they pushed back. So microorganisms have been part of our history for a long, long time. And I want to at least show some of the details of that history, right? The first thing that we need to understand is immunity. If you think about it, evolution proceeds at a speed for a particular species having to do with how long it takes for that species to reach sexual maturity. So if human beings take 13 years to reach sexual maturity, evolution in the case of humanity happens one step every 13 years. Now, social factors then come in and they, you have to gather a dowry, or you have to have a job before you get married, or you are now urbanized and you want to postpone having kids. Well, that makes it even worse, because now you get married at 20, you get married at 25, you get married at 30, or you postpone having kids. Well, now evolution is going to go one step every 30 years. Right? Microorganisms, on the other hand, reproduce, well, depending on the species, every half an hour, every 1 day, every 1 week. If we're talking about viruses, bacteria, and fungi. Well, that's a hell of a lot faster than we reproduce. So the question is, how could we have possibly ever defend themselves against them, right? In the time that it would take a mammal to develop a new kidney or a new way of protecting your nose against breathing, microorganisms that are airborne, microorganisms already found ways around those adaptations. So the solution that nature adopted was very interesting. Large animals take too long to evolve, so they will never be able to out-evolve microorganisms. So the solution found by nature was, well, if you cannot out-evolve them, then at least out-simulate them. And that is exactly what the immune system is. The immune system is a simulation of evolution. I'm going to put simulation in quotes, right? Because it's obviously not a computer simulation, inside our bloodstreams. Remember the formula that I gave you for evolution a couple of classes ago. Any population of variable replicators coupled to any filter or sorting device produces evolution. Now, in this particular case, the replicators are what we call antibodies. Everything in our body works at the molecular level, works through a lock and key mechanism. Right? Enzymes, like the enzymes that break down food so that you can digest it, or the enzymes that bring oxygen to hemoglobin so you can transport it to the brain and other parts, have a very specific geometrical shape that fits other geometrical shapes of other enzymes or proteins, just like a key fits a lock. And then it turns, and that's how the enzyme begins catalyzing, accelerating a chemical reaction or decelerating a chemical reaction. Everything in our bodies is a matter of timing, so enzymes are the ones that keep timing together. They accelerate this, they decelerate that, to make sure that everything is synchronized. And they do it through a lock and key mechanism. So the same idea works for the immune system. The immune system doesn't know what new diseases nature is going to throw at us, so it cannot manufacture specific defenses against them. So what it does is it manufactures millions and millions of keys, right, of molecules with a specific geometrical shape. And the lock, in this case, is proteins that are in the outer membrane of the invaders, the outer membranes of bacteria, for example. That, those are, whenever one of these keys finds a lock, then we know now how to neutralize that bacteria, right? So the bacterium itself acts as a filter. Or rather, not the bacterium itself, is what is called the antigen, just that part that acts as a lock. So the immune system produces millions and millions of keys at random. Those are the replicators. Whenever one of those keys finds a bacterium where it can actually lock in, that sends a signal, multiply this particular key. It's a good one. Forget about the other ones. You know, the other ones are made in 4 or 5 copies of each. Now make millions of copies of each. And by making those millions of copies in the bloodstream, all of a sudden we are now immune to that particular bacterium. Right? So it is a simulation of evolution, which I find fascinating, because speed-wise we could not possibly have competed against them, but if we simulate the evolution in our bloodstreams, we are now doing it as fast as they can evolve. So it's an interesting way of thinking about evolution, because it is, I gave you an abstract formula. I told you means and norms also can act as replicators. Well, now I'll give you one more example of replicator, antibodies, and one more example of a filter, antigens. Now immunity, of course, means exposure to the disease. And the number of exposed people in a city, the number of people that have become immune as opposed to people that are already susceptible, determines what our relationships with microorganisms are going to be. If we think of, now remember also, the population of humans in a city has one peculiar quality that is very different from the countryside, the density. You know, we are tightly packed in space. The more dense a city, the easier it is for microorganisms to pass from one human to another, particularly when they are airborne, but even if they are waterborne in saliva and things like that. The more people are in classrooms, the more people are in subways, the more people are in mass transportation, the easier it is for the disease to pass from one member to another. That same disease would die out in the countryside. So, the assemblage formed by population of bacteria, I'm going to put a population of germs, and a densely packed population of humans has 3 states, 3 possible states. And here I'm going to have to use formulas from immunology, but I'm going to tell you what the letters mean. Let me first write the formulas. Okay, so in immunology, or rather epidemiology, they use these little formulas here. RO is how many people will be infected by a single infected individual. It varies with a variety of conditions. The virulence of the disease, right? Smallpox and measles, for instance, which are very virulent, in fact they are considered to be today biological weapons, have an RO of 5 or 6, right? In other words, if I have smallpox, on average, I'm going to transmit it to another 6 people. So it has very high number of RO. Other diseases are less virulent, so one infected person only infects just another person. That number varies from disease to disease. And we're, by the way, only talking about infectious diseases, right? Contagious diseases. S, the letter S, is the proportion or the percentage of people in a city that had become immunized, or rather that have not become immunized, that are still susceptible to being attacked. Right? And then these 3 states, these 3 outcomes of the coming together of the 2 populations, right, the forming of an assemblage of the 2 populations, these are emergent outcomes and depend on those 2 variables here. S, by the way, is always normalized, which means, normally you say if 50% of people in a city are not immune yet to a particular disease, then S is 0.5. This is something that statisticians do. They take 100% and they make it 1, just to facilitate calculations. I'm telling you this because otherwise these numbers would not make sense. So, if the RO multiplied by S, by the number of susceptibles in a population, is greater than 1, that means that every germ will make 1.5 copies of itself, so to speak, or 2 copies of itself. Well, then those 2 copies will make 2 copies, that's 4, that's 8, that's 16, that's 32. It increases exponentially, right? That is an epidemic. That is why epidemics occur. It's an exponential growth of the germs. If, because the germs are very little virulent, or because the majority of people in a city are already immune, the product of RO by S is less than 1, the disease dies out. For obvious reasons, right? Every germ cannot even make a copy of himself, well, then the disease eventually dies out. So that's another emergent outcome. This is the most interesting one. If on average, RO multiplied by S equals 1, that is, if every germ makes a copy of itself, the population of germs doesn't grow, so it doesn't go epidemic, but it doesn't die out either. It remains in the population. That is the endemic state. Now, the endemic state can only occur in cities because the density of the population is the key here. In rural areas, which are very sparsely populated, diseases are typically epidemic. They always just go like wildfire, they kill all their hosts and they kill themselves. But in cities, they remain in the city and begin co-evolving with the city people. How does this happen? How can they ever exactly match the number 1? It would be almost like a magical coincidence, right? Well, no, because it's part of a process. Epidemics always occur in waves. So imagine that smallpox attacks a city, or measles attacks a city, or any other disease. At first, it's the first time that the city encounters, no one was immune. 90% of the city perhaps dies, but 10% survives. Some of them just happen to have the right keys. The antibodies are manufactured at random. Some happen just to have the antibody completely by chance, so they survive the disease. Some others don't happen to have the antibody, but they happen to manufacture it fast enough to neutralize the disease and become immune, but the majority of other people die. So now the city continues to grow, they have new kids and so on. A new epidemic comes back, but now S is a little larger, right, or a little smaller. Now at least 10% of the population is already immune. So the epidemic again hits, and again the same process repeats itself. A lot of the people die, but now an extra 10% or perhaps an extra 15% now survive. Some because they had the antibodies, some because they were very strong bodies and were able to survive. So now S is a little larger, or a little smaller rather, there's less susceptibles. After 4 or 6 epidemic attacks, most of the adult population has become immune, and now S is almost 1, and the only people left in the city that are susceptible are newborn babies, because immunity is not inheritable. So smallpox, measles, which are horrible biological weapons, become what we call childhood diseases. Mumps, whooping cough, there's a bunch of chicken pox, there's a bunch of childhood diseases, and I always wondered, why are they childhood diseases? I mean, are these bacteria evil enough to kind of plot, oh yeah, let's kill humans, but what would be like the worst thing? Yeah, let's kill babies, you know? And you can imagine it's like real evil bacteria plotting to just kill babies. Let's kill all people. No, all people are gonna die anyway. Let's kill babies. So the reason why it becomes childhood diseases is because of the dynamics of the process. The endemicity state is an emergent state for the assemblage, population of germs, population of humans, and produces a coexistence of diseases with humans in a relatively peaceful arrangement. Of course, a lot of babies die, particularly before we discovered a way of producing artificial immunity with first inoculation and then vaccination. But that was like in the 18th century, much later on. Now this is a very interesting state, and I'll tell you why. First of all, it only occurs in cities. So smallpox, measles, whooping cough, and diseases like that, all childhood diseases are urban diseases. And that, again, should give you pause when you begin thinking about culture and nature, because these are specifically urban microorganisms. In other words, our cities become the places where these organisms can survive and can evolve. So to me that's a fantastic thought, because again it brings back the materiality of the city. Is not just its buildings, its infrastructure, its transportation system. It's even at a biological level, right? And more importantly for the theme that we were talking about, colonialism, if you send people from cities where a disease has become endemic and they encounter epidemiologically virgin peoples from elsewhere, the disease immediately switches to the emergent state, epidemic, for obvious reasons. The new people are going to have an S that's much lower, the RO continue to be the same, so now all of a sudden the multiplication will give you more than 1. And this is exactly what happened outside of the Neo-Europes. The Neo-Europes were sparsely populated. You know, Native Americans were hunter-gatherers, and their groups were, 70, 100, 150. So when and it's the same thing in Argentina, the same thing in Australia, the same thing in New Zealand. So for white people to occupy those places as they do today, because, they don't belong there, they came from somewhere else, and yet they are the dominant ethnicity in the Neo-Europes. It was not only because it was a temperate climate and they found, something similar to their lands, but also because it was almost empty. And you can just send lots of people there. In particular, between 1840 and World War I, 60 million people crossed the Atlantic, beginning with the starving Irish, then the Germans, then the Swedes, then the English, and then at the very end of the tale, the peasants from, Italy and Poland and so on, And 60 million people is the largest amount of people that has ever crossed oceans, and perhaps the largest amount that will ever cross oceans, because there's no empty land anymore. Alfred Crosby calls it a Caucasian tsunami. And it's a very good word, because it was like that. It was 70 years in which 60 million white people come to the Neo-Europes and occupy them. Remember, in order for a colonizing adventure to have staying power, you need numbers. Those numbers is what the Crusades did not have. The Crusades had plenty of warriors, and then plenty of people wanted to go to Jerusalem and try to occupy it, but they never had enough numbers to basically have the staying power that they needed. They lasted 50 years and they would be kicked out, and then there would be another crusade that would fail, and so on. But the Neo-Europes today are occupied by Caucasians. I mean, there's absolutely no question about that. And it was partly because of the transformation of the land into supply zones, partly because of that gigantic Caucasian tsunami between 1840 and World War I. Now, Mexico and Peru were an entirely different situation. They were urban civilizations. They were heavily populated. There were at least 100,000 people in Mexico City when the conquistadors arrived. It is calculated that the population of entire Mesoamerica, which includes parts of the southern United States and all the way into all the way into the Mayan lands in Guatemala, Costa Rica, and so on, had about 100 million people. So you don't occupy those lands in the same way that you occupy the Neo-Europes. You need something else. You need epidemics. The Spanish conquistadors brought measles and smallpox, which of course were already childhood diseases for them, but unleashed tremendous epidemics in Mexico City, tremendous epidemics with the Incas, killing 7/10 of the population. When I went to school as a kid in Mexico, of course they give you textbooks of history and they explain to you why the Spanish conquistadors were able to conquer the Aztecs, because it doesn't really make any sense. Militarily, Cortés arrived with 513 sailors, 13 of which had muskets, and they had something like 7 horses. I mean, how are you going to fight an army that was in the thousands? And the Aztecs were not like wimpy little soldiers. You know, the Aztecs actually had institutionalized cannibalism, if you believe that. Of course, not for everyday consumption. It was for special occasions, but they actually fought wars continuously with other peoples just to get prisoners that they could then eat, right? Now, you don't defeat cannibalistic warriors, you know, even though they were still Stone Age. I mean, they wore metal, but mostly for adornments. The tips of their arrows were still stone. You don't defeat 10,000 warriors that are that wild with 500 sailors and 7 horses, right? I mean, there must have been some psychological effect. The horses were armored. The Aztecs had never seen horses. They probably thought these are monsters from hell. There were also other psychological factors. Hernan Cortés had blonde hair, and there was one legend among the Aztecs that Quetzalcoatl, one of their main gods, was going to one day, there would be a second coming of Quetzalcoatl, and he was a blonde god. So at first they might have kind of been thrown by Hernan Cortés' blonde hair, but psychological shock wears out, and you don't take over a city of 100,000 people that way. So what could have happened is this. As the Spanish conquistadors left Spain, people from rural places who had come into contact with babies that had smallpox or measles got the disease. With 3 or 4 of them in the ship would be more than enough. By the time you get there, and the moment you breathe into these people, you start an epidemic. Right? And of course, the locals would see everybody dying, but the conquistadors, who were already immune, and that just added to the psychological idea that they were gods and they were more powerful. The actual weapons that the Spanish brought may have had a little bit of an impact because, of course, there were fire weapons and the Aztecs had never seen that, but you have to remember what a musket is. A musket is not a rifle, right? A rifle, you load it from the breech because the bullet already has the gunpowder inside the full metal jacket, so you don't need to you need to seal the breech so that the gases don't escape. You can load it from the breech, and that means that the muzzle can have a groove on it, so that the bullet, which now is conoidal, very aerodynamic, comes out of the rifle spinning, and that stabilizes in midair, which means that you can shoot somebody very, very far away with a rifle, and you can load it very, very fast. A musket was not at all like that, right? A musket had to have the breech sealed because you first had to add the gunpowder. So imagine you're a conquistador, you have an Aztec over there, right? I'm going to show you the power of Europe, man. So that you take your little gunpowder bottle, take the thing there, you put it over here, right? Then you take the ball, just a second there, take your little bullet, which is a sphere. You put it down in, and then you have to take that stick, right? And then ram it down. Of course, by the time you ram it down, the ball is like this, and it's going to come out flying like that, right? And it's taking you so long that the Aztec is going, man, shoot me already. The suspense is killing me. So muskets were useful as weapons when you had an army of 1,000 people firing muskets at the same time. That's the way battles in Europe fought with muskets were done. You have thousands of people firing at the same time. Then it doesn't matter whether you're actually hitting something, because you're shooting 1,000 muskets simultaneously. You had to hit something. And the armies of the enemy, or your rival, were lined up in front of you, so it's not as if it was that hard to hit something. But in a colonial adventure, muskets were useless, completely useless, except for psychological shock. So once you begin to rule out all the other possible causes of the defeat of the Aztecs, the only possibility open is urban diseases, right, that have been brought from Europe to America, that went in an emergent way from an endemic state to an epidemic state and killed 7/10 of the inhabitants of Mexico, and then did a similar job in Peru. Without these microorganisms, Hernán Cortés and Pizarro would have never been able to conquer these people, or at least not when they did it. They might be able to come back later on with larger armies and much larger ships and be able to take over these lands. But diseases just opened up the land that they needed, right? And of course, left a bunch of disoriented survivors who now had lost most of the community members, so they were not parts of communities anymore. Their assemblages, communities, organizations had been decimated. They were now kind of disoriented individuals that were very easy to digest into the tissues of European culture. In other words, they were very easy to Christianize. Right? When you read the letters that the Jesuits would send the Vatican, yeah, we baptized 100 more Aztecs today, and the following month we baptized another 1,000. But you don't change people from one religion to another unless you have disoriented them so more with a biological attack that they have no choice but to believe in your God. Right? So anyway, that shows you a very different material flow, but it's also an urban flow. Right? And I'm giving you this detail, guys, remember, because I'm right now dressing up, I'm adding detail to the bare bones model that I gave yesterday. Yesterday, the whole idea was just to clarify the ontological status of all those entities that we talked about. They were all individual entities. They had a date of birth, they had a date of death, and they had certain emergent properties from the interactions of their parts. But then the next step is always to take each one of those entities and begin doing what I'm doing right now. Adding layers of biological detail, adding layers of linguistic detail, adding layers of technological detail, adding layers of you name it, right? In order to now get a much more embodied, much more fleshed out version of an assemblage. Okay, we're going to take a break.